Okay, well, welcome. This is lesson 4.7, and it is measuring elapsed time. As usual, I've got my favorite guest who comes by the most to be in the video. Say hi.
Hi.
Yep, there's Ben. So if you're scratching your head and thinking, wait a second, all chapter long, and Ben, you've actually been in a bunch of these videos even though you're in pre-algebra, we've been doing all this fraction stuff, right? You know, adding, subtracting, fractions, mixed numbers, borrowing, carrying. What the heck are we doing talking about time? Well, the reason time is in this chapter is because really this is an exercise in borrowing. Part 2. So we just finished 4.6 where we were borrowing when we were doing mixed number subtractions. Well, it turns out that that same kind of borrowing we were just doing with fractions and mixed numbers is the kind of borrowing that we do with mixed time, or with elapsed time. So to show you what I mean, let's start with some easy examples. So elapsed time. What we're talking about with elapsed time is basically if we started recording this video at 4:21 p.m. and we finished at 4:36, how much time elapsed? How long was the video? So we just basically say, what's the difference between here and here?
15 minutes.
Right, and so you can do the math. If you can't do it in your head, you would do the math by you would start with the end time, and you would subtract the begin time. And whatever the difference is, as Ben just said, it's 15 minutes, and we're going to make sure we always label our answers, so we don't want any math curves. No naked numbers, but we get 15 minutes. Okay. Now sometimes the problems. Here's another example. We go from 3:15 to 5:45. So again, we'll put 5:45, okay, which is the stop time when we ended, and we always subtract the start time. Okay. So we're going to subtract 3:15. And how long did we spend? Let's say this is Ben's after school. He went to study hall, and then he's going to be in practice, let's say, till 5:45. So if he left here at 5:45, how long was he in extended day today? So we'd subtract, and we'd get 5. Actually, subtract from the right. 5 minus 5 is 0. 4 minus 1 is 3. And 5 minus 3 is 2. Okay? And now the dots mean time. So actually, at this point, we want to rewrite this. We want to be a little careful. Some people write 2:30, and we know what that means. But 2:30 is a time.
Yes.
Okay, that's not really a good notation. Let's cross it out. So really what we mean when we get 2:30 is he's going to be here for 2 hours and 30 minutes. Okay, it's different than the time. So even though that's kind of what the colon means in a time, that the first number is the hours and the second number is the minutes, when we're talking about elapsed time, we want to write it out like this. Okay, makes sense? Yep. Okay, so that's the basic idea. Well, again, what does that have to do with carrying or borrowing or fractions or mixed numbers? Well, what if Ben took a couple minutes to go to his locker? And so he didn't get done with, he didn't go to extended day until 3:18. And let's say, that's a but. So, but, what if we go from 3:18 and he doesn't leave until 6:05 tonight? All right, so let's go ahead and try and do that same thing we just did. Okay, so we'll take the end time, and we'll, oops, that was supposed to be yellow. All right, we'll take the end time, and we'll subtract the start time. And if we do that, we're going to have 6:05, wow, stylus isn't working today, minus 3:18. All right, and here's where the problem comes in. All right, clearly this is going to be about 3 hours, right?
Yeah.
All right, so we got plenty of time there. The problem is, can you take 18 away from 5?
No.
No. So just like we did with mixed numbers, we're going to have to borrow. We're going to borrow from the 6, and the 6 is going to become a 5. Now, I want you to think about this, Ben. If you borrow from the hours, how many minutes do you get for that?
60.
Right, you get 60. So instead of adding the bottom and the top of the fraction together like we did with mixed numbers, we're going to always borrow 60 minutes for every hour over here that we borrow. So this is going to now become 65 minutes. And now I can subtract. Okay, so start from the right. 5 minus 8. Well, you can't do that, but this is just a regular borrow. Borrow from the 6, that'll be 5. This will become 15. Agreed? 15 minus 8 is 7. 5 minus 1 is 4. And 5 minus 3 is 2. And again, we're going to resist the temptation to copy these colons, and instead we're going to put an H and an M-I-N in. So it's 2 hours, 47 minutes of elapsed time from 3:18 to 6:05.
Yeah.
Okay, so there's a good example of what I mean when I say that this is borrowing part 2. Okay? Well, let's do another one of those. Let's practice this. We've got another issue here. Suppose we start at 11:20 a.m. and let's say Ben comes late to school. He doesn't get here till 11:20, and then he leaves at 3:15 p.m. So he's only here for part of the day. How long was Ben here at school? Well, okay, again, we've got some problems we got to deal with here. Okay, first of all, let's go ahead and write the stop time down. All right, and then underneath it, let's write the start time. And right away, you see a problem there, don't you?
Why is that large?
Yeah, we got a problem because you can't take 11 and something away from 3 and something. Oh, you could if you got negative numbers, but we're not going to get to that until pre-algebra. Okay, but clearly there is a positive time here. You can kind of estimate here. It looks like Ben was at school for about 4 hours, right?
Yep.
And sure enough, if you look at a clock from 11:20 to 3:50, in fact, if we went to 3:20, it would have been 4 hours. So the problem is this AM-PM switch, and it's not really exactly an AM-PM switch, because if he came in for just a little while and didn't feel well and went home at like 12:55, we'd be fine. And technically at noon, we switched from AM to PM. So really the switch happens at 1 o'clock. Because at 1 o'clock, think about what happens with the way we tell time. If you are sitting in your advisor waiting to go to lunch and it's 12:59, well, look at the number. It's a really big minute, okay, hour and minute. The very next minute, it switches to 1 o'clock. Now, if we were in the military, we'd be fine, because in the military, they don't use AM, PM, so in the military, from what comes 1 minute after 12:59?
1300.
1300 hours, which is 13.00.
hours.
And so that would be real easy to set up, 1300 minus 12:59. Okay, the only thing we'd have to do, we would have to borrow, correct? We'd have to borrow from the 13, this would become 12, and this would become 60 minutes. And 12 minus 12 is obviously 0, but 60 minus 59, sure enough, is 1 minute. Yep. Okay, we got the idea. All right, so the same thing has to happen here. Now, we don't have to necessarily move to military time, but what we have to do when we realize that we've gone past one of the 1 o'clocks is we have to add 12 to the end time. So instead of 13:15, think about if we were in the military, we would actually have gotten out of school at 15:15. All right, and now we're good to go. All right, so 15:15 minus 11:20, now we're taking the smaller number away from the bigger number, so that's going to work. We still need to do the borrowing like we did before. So let's borrow. We can't take 20 away from 15. Don't ever be tempted to subtract going the opposite direction. Okay, you cannot do that. So what you have to do is make sure the top number is always bigger. So we're going to borrow from the 15, which will be 14. We borrow 60 minutes, so we'll get 75 minutes over here. All right, agreed? So 75 minus 20, let's just do that. It's 55. That's in minutes. And 14 minus 11 is 3 hours. And as we said, we approximated that it would be about 4 hours. And sure enough, Ben was at school for 3 hours and 55 minutes. So there we go. All right? Okay, so when we're doing elapsed time, basically they're going to be subtraction problems. Quick review. It's always stop minus start. Okay, which just makes sense. And if you get stuck on that, just make an easy example. Have something start at 10:05 and end at 10:10. Clearly, we all know that took 5 minutes. Okay, now how would you set up the subtraction problem? You'll quickly realize that the stop time has to go on the top, and the end time, or the beginning time, goes on the bottom, and you subtract, and that's how you get 5 minutes. Okay, so if you get stuck, just prove it to yourself which way it goes. Don't try to memorize this necessarily, but that is how it goes. Okay, also, we learned how to borrow from the hours, and we learned what to do at 1 o'clock when we go from AM to PM. And the same thing would happen in the middle of the night when we go from PM at 12:59. If you stayed awake till 1, 2 o'clock, you'd also have to do the same thing there. And that's not quite military time, but you do the same thing. You would add an extra 12 to the end time. All right, so there's still the worst example. What if something started at Monday at 8:30? Like say you had an experiment, and it went all the way to Friday at 3:15. Or you wanted to find out how much elapsed time there is from 15 minutes into school on Monday morning until you can finally be done and say TGIF on Friday. All right, now this is a much more difficult problem because what's going to happen as you go through the day is you have Monday AM, PM, Monday AM, PM, Tuesday AM, PM, Wednesday AM, PM, Thursday, we'll use an R for Thursday, AM, PM, that's what they use in college, and then Friday you have AM, and you finally get to PM on Friday. All right. Every time you went from AM to PM, or really somewhere real close to that was on 1 o'clock. Okay, so there's one right here on Monday morning about noon. There's another one Monday night while the late night talk shows are on. There's another one Tuesday around lunchtime. We go, well, hold on a second. I think I goofed.
Oh.
So let's see. From Monday, right here, this is from p.m. to a.m. That would be at about 1 o'clock. Well, it's really at 1 o'clock in the morning on Tuesday morning. Then this one goes from a.m. Oh, I'm sorry. I got to back up. Yeah, I'm supposed to go to every one of these. Okay, so I put those a little too close together. Okay, so this is the late night talk show one. This is lunch on Tuesday. Okay, this is late night talk show Tuesday. Lunch on Wednesday. Late night talk show on Wednesday night, Thursday morning.
Lunch.
And then lunch again. And then 1 o'clock in the morning on really Friday morning. And then finally lunch on Friday. So for every one of those transitions, and there's quite a few of them there. Okay, let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9. That would be 12 hours we have to add to the stop time. Okay, so once again, that was what, 9? So we first have to figure out what 12 times 9 is. And so we do the math, and we get 108. That's 108 hours I have to add to the end time. So instead of 3:15 on Friday, it's really going to be 111:15 is my stop time. So essentially, as I fast forward from 8 o'clock, and that makes sense because it's about 24 hours in a day, right? So 5 days ought to be in the neighborhood of about 100 days. And it's not a full 5 days because we're already 8.5 hours into Monday, and we stop pretty early in the day on Friday. So that is exactly what we have. And then we're going to subtract 8:30. So that's 8:30. And all I've got to do to wrap this problem up is borrow. Well, I can't take 30 away from 15, so I'm going to reduce this down to 110 hours, and that gives me 75 minutes again. And now I subtract. 5 minus 0 is 5. 7 minus 3 is 4. 110 minus 8.
Or you could do 10
well, let's
minus
actually
8.
let's
Just
actually
do 10 minus
borrow
8,
here. So we'll do 10 minus 8, which is 2. Bring down the 1. So we're going to get. Oops, I made a mistake.
No, there's another.
Yeah, there's a 0.
No,
there.
it's only 102.
No, I skipped the 0 right here. Okay, so we'll make that into a 0, and we'll put the 1. So it's 102 hours, 45 minutes. Okay, so think about that on Monday morning. So Monday morning, when you look up the clock the first time, just think there's only 102 minutes, 45 minutes until you get out of school on Friday afternoon. All right. So now that's an extreme example. Usually an example won't be nearly so bad. It'll be something starts at, let's say a person is a nurse.
Like only 2 days or something.
Right, let's say a nurse, well here, let's just say a nurse goes to work at 10 p.m., okay, and she works until, let's say she works a really long shift. She works a double shift, so she works till 4 p.m. the next day. Okay, so we have a conversion, so a.m. would be in here. So there's going to be a 12-hour conversion at 1 a.m. There'll be another 12-hour conversion at 1 p.m. So you'd end up 24 hours. So when we did the subtract time here, it would basically be 24 plus 4 is 28 minus 10. So that would be a total of 18 hours of continuously working. That is one very tired nurse by the end of that. Okay?
Yes.
But that makes sense, right? So basically she worked all night on, let's say, whatever day. Let's say she started on Monday. She worked all through the morning the next day until Tuesday afternoon. So, yeah. So 18 hours is really working a long time. Okay, and we'll label that. So that's the idea. All right, so let's wrap this up because it's getting a little long. So Ben wanted a 3D picture of himself. So there we go. So that is the Ben box.
3D.
The Ben box. Or the Ben rectangular prism. But thanks again for watching, and we'll practice elapsed time tomorrow in class. Remember, it is stop time minus start time. That would be an excellent question for your daily quiz. We'll see you later.
Bye.